Imagine replacing one of the world's largest AI data centers with a computer small enough to fit inside a shoebox. It sounds impossible, yet scientists believe superconducting technology could make it a reality, and it could completely change the future of artificial intelligence. Welcome to DAMISICOTECH, where we simplify the biggest AI breakthroughs, explore cutting-edge technology, and show you how every innovation can become your next business, career, or investment opportunity. Today's AI revolution is creating smarter chatbots, realistic image generators, autonomous robots, and AI agents capable of handling complex tasks. But behind every impressive AI model lies a growing problem that few people ever think about: power. Most people assume AI consumes huge amounts of electricity because of complex calculations. Surprisingly, one of the biggest energy drains is simply moving data between processors, memory, and storage. Every second, billions of pieces of information travel through microscopic electrical pathways inside computer chips. As that movement increases, so does energy consumption. There's another problem. Traditional computer chips use metal wires that naturally resist the flow of electricity. Just like friction creates heat when two surfaces rub together, electrical resistance turns valuable energy into heat. That's why modern AI data centers rely on enormous cooling systems running 24 hours a day. As AI models continue to grow, so do electricity bills, cooling costs, and the physical size of these facilities. Instead of asking how to make today's chips slightly better, researchers are asking a much bigger question: what if electrical resistance could almost disappear? That question leads us to superconductors. A superconductor is a special material that, when cooled to extremely low temperatures, about 4 Kelvin or minus 269 degrees Celsius, allows electricity to flow with virtually no resistance. Instead of wasting energy as heat, electrical current moves almost effortlessly through the circuit. This isn't just a scientific curiosity. It could solve one of AI's biggest challenges: delivering far more computing power while using dramatically less energy for specialized workloads. But eliminating resistance is only part of the breakthrough. Traditional computers rely on billions of transistors to process information. Superconducting computers take a completely different approach by using tiny structures called Josephson junctions. These devices switch information using extremely small magnetic flux pulses instead of conventional transistor logic, allowing operations to happen at remarkable speeds while consuming very little energy. Researchers believe these specialized systems could eventually operate at frequencies of 20 to 100 gigahertz for certain applications, while consuming thousands of times less energy than conventional computing architectures. But here's where the story becomes even more exciting. A revolutionary technology means very little if it can't be manufactured at scale. That's exactly what scientists are working on next. That that no, recent research is making that goal look more achievable. Scientists are exploring ways to manufacture superconducting circuits using existing 300 millimeter silicon wafer production techniques. Instead of rebuilding the entire semiconductor industry, they are adapting proven manufacturing processes with advanced superconducting materials such as niobium titanium nitride and improved insulating layers. If successful, this could accelerate the journey from research labs to real-world AI infrastructure. At this point, you might be wondering, if these computers need to be cooled to temperatures close to absolute zero, won't that consume enormous amounts of energy? Is a fair question. Cryogenic cooling is expensive, but for massive AI data centers running around the clock, the energy saved during computation could outweigh the energy required for cooling. That's why superconducting computing is being explored for large AI facilities, scientific supercomputers, and future cloud infrastructure, not for smartphones or everyday laptops. Another exciting advantage is chip density. Because superconducting circuits generate very little heat, engineers could potentially stack multiple computing layers on top of one another. More computing power in less space means future AI systems could become dramatically smaller while delivering significantly higher performance. This is where the idea of shrinking warehouse-sized AI data centers into compact systems comes from. It's an ambitious vision, but one grounded in active research rather than science fiction. So, what does this mean for you? Every major technology shift creates new opportunities before it becomes mainstream. As AI infrastructure evolves, demand will grow for cloud engineers, AI infrastructure specialists, semiconductor experts, automation consultants, data center designers, technical educators, and AI entrepreneurs. Even if you're not building superconducting chips, understanding these trends early can help you position yourself for tomorrow's opportunities. This is why learning about AI isn't just about following the latest headlines. It's about recognizing where the industry is heading and developing skills that remain valuable as technology evolves. The people who prepare early are often the ones who benefit the most. Today's breakthrough reminds us that the future of AI won't depend only on smarter software. It will also depend on revolutionary hardware capable of delivering more performance with far less energy. Superconducting computing may still be in development, but it represents one of the most promising directions for the next generation of AI infrastructure. At DAMISICOTECH, every breakthrough is more than just news. It's your next opportunity. We don't just follow technology, we help you turn technology into opportunity. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you never miss the next AI breakthrough. Share your thoughts in the comments. Do you think superconducting computers could transform the future of AI, or will traditional silicon remain dominant? Share this video with someone who loves technology and join our Telegram and WhatsApp communities for even more AI insights and opportunities. Thanks for watching, and I'll see you in the next Damisico Tech Deep Dive.